Welcome to the Data Coffee Break podcast. I'm Mark.
And I'm Christian.
If you are passionate about data like us, take a seat, relax, and join us to our coffee break where we discuss all things data.
And remember, there are no filters, no PR.
It's just a real life experience. So let's begin. Do you want to introduce our guest, Christian?
Absolutely, because today we have a data practitioner that started working as a metrology engineer, mechanical engineer, and also made the transition to data engineering. He has worked for companies such as Jaguar Land Rover, Calusa, and Oxwash. In my opinion, he is one of the sharpest and most passionate data engineers that I have ever met. He's a dedicated cyclist, and you can also find him playing Magic the Gathering. With us today, we have Denis Zaboronsky. Welcome.
Welcome, Denis.
Thank you. Excited to be here.
What was the jump actually to move from basically mechanical to data engineering?
I changed into data when I moved to Calusa during COVID.
Right. So during COVID, you moved into Calusa into data engineering from being a mechanical engineering.
Yeah, into data analytics. Yeah.
You learned on the go directly, or do you took some specific extracurricular diploma? I don't know if we can say that.
Like Udemy courses.
Udemy course. There we go.
And then got a job as a junior analyst, and eventually went, no, it's not quite analytics. Wasn't quite right. It was data engineering that I wanted to do, and just internally transferred there.
I remember one time that we were having a conversation on a Monday, and the typical question, like, what did you do during the weekend? And you say, like, oh, actually, I learned how to code Golang. I was like, okay, so that's very casual. You have the skills, and it's really cool that you can actually pick up, using Udemy or any platform out there.
Yeah, it was good fun. A bit of Golang, not code in Golang.
So, Denis, you are a data engineer. A lot of our listeners, they are more on the, let's say, on the product side. So for our episode today, we would like to actually focus on the real world of data integration and data pipelines, right? So how a data engineer goes into their day-to-day, how you actually work with any technology. And I guess from a point of view of this is that we always talk about the challenges. We talk about like deep multiple sources and how you bring everything into one place, how you integrate your data pipelines. But in your experience, is that really the main challenge for a data integration team? Or what is your favorite challenge, I would say?
Favorite challenge is probably different to my biggest challenge, right? Because I think they're different things. And yeah, I think it's a really good question. I probably will start with like my biggest pain point. So for context, I do a lot of work preparing data for analytical consumption, which means for like either for PMs and project managers to do self-serve via like quite well-refined BigQuery tables or whatever warehouse you have, where they can hook in with something like Looker or Looker Studio or Tableau, or for analysts to do like more in-depth analytics. So the team I work in, we look on making sure that data is available and easily usable. And a big part of that is sometimes hooking into data produced by internal teams and sometimes taking data from other sources and then standardizing it. So one of the things that I found really an interesting challenge in my career is actually dealing with poor data quality. So this is something that you're laughing at me, Christian, because we've spoken about this at length, but data quality is like a really weirdly misunderstood thing, I think, sometimes. So you'll often talk to an engineer or a software engineer, and you'll say, okay, so how are you guys ensuring that what we get from a data source that we need information from is good, right? You can imagine this is like when they prepare their API, how do we make sure that the API gives us good data? And the typical answer is, well, we've got a test suite of unit test and integration tests that means we're fairly confident that our service, our API is going to give data back in a really like structured and effective manner. And actually, in my experience, unfortunately, that's often not very true because the thing that happens is their service is written for like a very specific use case, but edge cases are a big thing. And writing unit tests and integration tests for all edge cases is incredibly hard. Now, I think this is where data engineers have a really cool part to play, because data quality testing on top of all of the data, agnostic of whether it's been produced by a unit tested service or not, means even if that API has produced something that it wasn't expecting to produce, we catch it and we can flag it and we can help define the edge cases and we can help the teams learn. I think there are some amazing tools out there. There's lots of different ways of doing this, but the biggest challenge is sort of this concept of getting good data. I don't know. Do you guys think that makes sense?
I guess it's like the main introduction, as you say, like what many people will see as an issue. And I like how you put as an analogy between software engineers and the data world where there is a gap. You see like the difficulty or to apply the same principles, but some other difficulty arise in this case for sure here.
Yeah, actually, I remember this article from 2016 where bad data costs around $3 trillion, trillion with a T. But it's interesting that you put there, Denis and Mark, because we talk about that there are products, but it doesn't seem that one product can solve all of this, right? Because maybe the types of data or the velocity of the data. What do you guys think that why this hasn't been solved, right? Or maybe there is no solution and you need to code it.
I think that it's an interesting one, though, because it comes back to something you talked about in your data trends podcast, I think, which was data contracts and the concept of data contracts, right? They maybe think that their data is being consumed. So imagine you have like a message bus, so like Kafka or PubSub or something like that, and a team pushes into that message bus. A lot of the time, they just think, right, that's gone, that's off my hands. It's kind of up to the consumer, whoever that may be, to hook in and deal with it, regardless of whether it's good or bad. And there's no concept of a contract saying, I guarantee that my data is of a certain shape or a certain quality. And I'm being a bit unfair about shape. You can do things like use a strictly enforced Avro schema or whatever to make sure the shape is strict. But often there's not like a good layer at the point of production to stop the data from being pushed to the message bus. So the interesting thing for me that I've thought about trying to implement, and it can be complicated, is the concept of a DLQ, but at the point of production.
Can you explain what you mean with that?
Yeah, so there's a concept of called dead letter queues, which basically means as you receive a piece of data, you validate it or receive a packet, you validate it before you do anything with it. And if it's bad, you actually push it into a different message queue, or you store it and you flag an alert and you go, okay, I need to deal with this later, but I know that there's a problematic piece of data that I haven't processed. Now, for me, if there was a contract saying, like a data contract saying, I guarantee that the data I'm producing is going to be fit for consumption, you would have that almost as a step before you release to your message queue or to your message bus, and you actually refuse to publish messages that don't conform to a certain level of standards, right? And your contract within the company, your data contract, or even externally, if you're doing it via an external API, would say something like, I guarantee that my data conforms to this level of testing, which might be X, which is like, but I've never seen this implemented, right? And it's quite hard to implement because I think it's really hard to convince teams sometimes of the value of doing this kind of test, because they go, well, my unit tests work. Yeah, okay, that might account for 80% of your cases or 90% of your cases, but the stuff doesn't account for what's the potential impact that you're having, because it's one thing for analytics to get it and go, okay, well, our analysis looks wrong. It's completely different if you imagine that another consumer is also taking that same piece of data and then trying to do something with it and has an imperfect solution for dealing with bad data. Or even worse, you have multiple consumers that handle that incoming packet differently for the same error, right? And that happens. That legitimately happens, right? And this is where data contracts, I think, need to start to get stronger. But it's an incredible pain point as an engineer, like a data engineer going, I'm going to take data from you, but I don't trust any of it. So I'm almost applying a zero trust philosophy to all data that I consume. And that is genuinely what I do. The first thing I'll do is I'll always write data quality tests for incoming data and try and figure out whether it's good or bad.
Yeah, you put it in a very good way there, right? The importance of this new emerging trend right now feels like a buzzword, but definitely there is a niche or a place for disruption there, right? When we talk about the complexities of integrating data, do you see, for example, nowadays more latency being a problem or privacy, or that actually comes... Well, I say two very distinct variables there, right? But this should come before, for example, things like latency or performance when it comes to how important that is, actually, that data quality.
I love this question. So ahead of security, no, absolutely not. Nothing should come ahead of security, in my opinion. Like, if, you see these big data leaks and stuff that happen online, and that's pretty bad. And so your pipeline should always be secured first, in my opinion. That in terms of performance, I think data quality does in general need to come ahead of latency, especially in my world where I'm very analytics focused. So I have a slight bias. Latency is not that important. Like, you're often looking at historical trend analysis or just general trend analysis, where if the data is an hour out, an hour stale, it really isn't going to make a huge difference. Like, honestly, so you're better off making sure that you have good data and you know that there's a problem over focusing like, a 10-second latency. But actually, this is a really good point, Christian. So one of the things that I've struggled with in the past as a data engineer is the concept of SLAs, right? And this covers kind of summarizes all of these points, because you can go to your stakeholder and say, well, what's my SLA? And what am I agreeing to provide to my internal customers or even external? We've done analytics. I've done analytics work where I provide it to an external customer. How fresh does my data have to be, right? People don't tend to have an answer for this because it's not typical. It's not like a really obvious use case where someone's sitting on their mobile phone. You expect the app to respond really quickly. So the answer isn't always very obvious. And so since people aren't pushing me on like speed, I would always prioritize them like security first, then quality of the product, because it's going to give you much better insight. And especially with machine learning becoming so much more popular, bad data in, bad output out. Like, I cannot stress how important I think data quality comes within that.
You mentioned SLA, and we see emergence of some tools in the market using the word data observability. Do you see them like already like being in use and solving this kind of issue you're having, or they're actually not the only answer in this case? Because I feel from what you explain, it's part of like, let's say, a job in a data engineer to basically put this kind of checks in place, and doesn't necessarily always require this kind of tool, right?
It's an interesting question. I've definitely come across data observability tools that have some strengths to them, where they can start to pick up on things like trend analysis. So some tools are machine learning based, these observability tools, where basically they say my throughput of data volume has suddenly like changed drastically, and therefore this is a problem, right? And that is really good, and I think there's a really good place for that. They can be expensive. I have opinions about whether they should be as expensive as they are based on what they're giving you. The one thing that they often miss is the internal business logic, which is kind of, I think I haven't even stepped back far enough to look at these observability tools yet to see the value from them. The big thing is things like fields fundamentally not behaving like in an expected manner, which is causing problems. Like, forget trend analysis going, oh, you're suddenly 20% lower on throughput today. Yeah, sure, that's a problem. That's very similar to a lot of DevOps observability stuff. Is it really that different that we would do something like use a Datadog monitoring tool or Datadog type monitoring tool, Google monitoring, to say, I expect X number of messages or X number of rows of data to go through? No, it's not. I think there is a place for it, but the kind of quality I'm talking about is not actually even at that level. It is, these messages just don't make sense. And if you look at it as a human, you can be like, this is a weird acting field. And
they just don't take the logic of the business logic needed first. They're using standard models.
I feel like the more that I see the trend in terms of after, for example, all the cloud data warehouses make data to come so fast and so easy into it, now we see that the trend is going backwards, right? Like, now the issue is actually at the source side of things, where your role there, Denis, as data engineer, is becoming I'm not saying that it wasn't popular, but it's becoming more and more relevant to me, right? To the business, because now the business understand what is the actual value of having the good data engineering teams. I mean, because you work with teams, and this is for our audience that would like to, for example, explore data engineering, right? As yourself, as you did. Do you see like multiple disciplines, I want to call it, as data engineer?
To answer that question, it's complicated in a sense. There's a couple of things that I actually am starting to see. The first one is more software engineers that are taking on that understanding of the early data pipeline stuff, where they are starting to understand more about the data they're producing and how they make it easily available for, analytics focused folk to start to hook into it. So that's definitely a trend. So like people figuring ways to write directly to the data warehouse and stuff like that from their message buses that they might already be using.
Yeah.
I think that's one thing that I see, and that's not necessarily new data folk. It's actually more the traditional software engineering folks. So migrating that way, which is nice, actually. I think that wasn't necessarily a big trend for a while. But within engineering, data engineering, there are a couple of common terms that I've come across. One, which is an analytics engineer, which is starting to become really...
Oh, yes.
Yeah. So this is starting to become a really common term, especially with tools like Dataform and DBT, right? And it basically has been popularized, in my opinion, by the fact that these warehouses are as powerful as you said, Christian. It's now easier to just follow this ELT, which is extract, load, transform moniker, where actually we get really raw data in. And because it's so easy to write SQL, if we start to structure that SQL and review it properly, you basically can start to get a lot of value out in like quite lightweight data pipelines. So I had a lot of experience with analysts that are actually interested in progressing in like a technical or engineering sense, really loving this role and like really drawn to this role because you get more interactions with things like GitHub and CI/CD as it starts to automate all these deployments and like really getting interested into this role. And I think it's really cool to see. And I think what then you start to need a little bit is more like these kind of data ops type guys that are focused a little bit on tying it all together. So you can imagine like if your producer is making the data easier to hook into and your consumer is sort of able to like do more and more with it because their SQL is going further and further using something like these tools, your main focus starts to be just like to marry them up together. So a lot of IAC and a lot of CI/CD to secure it, because I think one of the things I've noticed is both analysts and engineers have one thing in common, which is they're really used to looking at within their domain, and their concept is within my domain, data is secure because I've got it within my four walls. And it's just making sure that anything in flight is staying secure. And so I do think these kind of data up users need to be aware of that. And it's kind of creating that nice interface layer. I think it's quite technical. I don't think it's necessarily product focused. I think analytics engineers, at least in my experience, end up taking on a lot of that product focus, especially if you're lucky enough to have them in your team, right? Because they tend to be really awesome at interfacing with with like pure analysts that are more looking to visualize or data scientists to make sure the curated layers and the data models that they create are really, really like high value to them.
And they might be like working more like with a business logic and direct business need as well.
Exactly right. And so in my role, for example, where I sort of recessed a bit more into that pure data engineer role, I focused weirdly a lot on infrastructure as code, because there are so many really cool tools. I'm not going to write a better tool than what some of the powerhouses are going to write. I'm often going to get a lot more business value just by being able to deploy it effectively, deploy it through my environments effectively and test it, and then create links. And then writing super lightweight tooling inside containers that just fixes the small missing gaps and deploy it all, and then ensure that we have like active monitoring on the system. That's a big part, I think, of data engineering. It is sort of making sure your alerts and monitors are relevant, and look at things like security, which is something that, if you're just sitting in DBT land or Dataform land, you're not necessarily thinking about, but actually there are like packages that are sort of being used under the hood for all of these systems, and you're not, you don't want to think about that. We try and take that away from them, right?
It seems like from what you just described here and the topics you have before, anyone going into this role, and I'm pretty sure for the audience, some people are just starting in the industry, that's a lot of different tools, basically. When I also look online, because if you look for ingestion, transformation, etc., there is always like a bunch of tools you might get involved for one of this step only as well.
I think, yes, I mean, to your point there, Mark, and what you actually raised there, Denis, is the concept now of data ops, right? Because now the pipeline is so long that you have the integration, the ingestion with different tools and packages. I tend to say that because my background, well, I started as a software engineer. Well, I mean, that was like a long time ago. I don't think it's relevant anymore for my JDK6 experience, but all these practices of having GitHub, of having, like a continuous integration, continuous development, were on the software side. And now we are bringing them to the data side. And it's interesting there, Denis, I mean, in your experience, this is something that is taken by a different team? Or this is something that is, like the data engineer, the data pipeline should be top of all of those concepts?
It's a good question, right? I think that, I personally think that there's this philosophy that every good software engineer should be able to apply DevOps principles to a lesser or greater extent within their work. I don't think that data engineers should sit outside that. I think it can be a slightly strange thing to do, to discriminate the two as like separate roles. And actually nowadays they are getting closer together in many ways. I think, and this is anecdotal because I have only, interviewed a handful of people and discussed these things with a handful of people, but I definitely see that having good CI principles just makes your deployment speed much faster. And we know that that's true in software engineering, and that is true for a specific reason in software engineering, right? That people keep going to these DevOps principles and keep trying to understand that. I basically think that if you're a developer of any kind, a data developer, software engineer, you will always need to try and apply DevOps to a certain extent. Even analytics engineers. Best example I can give is at some point I worked on a pipeline that was for deploying Dataform and making sure that Dataform configs were valid. And for anyone that doesn't know, Dataform is an awesome tool for SQL integration. It just made people's lives easier. And we had analysts running through this framework. They didn't necessarily need to know it, but they knew that they could submit a pull request to GitHub and they would get validation back saying, okay, you've actually done something silly in your config, or you've written something that's invalid. So I think that all people that work in data should at least look at it, have at least a vague understanding.
That makes a lot of sense. We were discussing, Mark, the other day about it. That's why DBT and Dataform made it very well, right? That included these principles as part of the development, right?
Yeah.
I mean, going into real-time analytics, Mark and I always try to start from define real-time. Are we talking about 1 second, microseconds? I mean, what is actually real-time? Do you see this as a trend coming more? Like real-time, I'm talking about streaming, not micro-batching as part of your role?
So this is a really good question. And it really depends on a lot of factors. I think the first factor that a lot of people I don't think necessarily consider is what do you want to learn from the data? What's the benefit of real time? Because we all know, I think you don't have to read too far to understand that a real-time system is going to be more complicated, more expensive because it's always on. So serverless stops being as effective especially if you're a small company. But it is a sexy buzzword, right? It's kind of like machine learning was a sexy buzzword. And then people realize that if your data is bad, your machine learning is not necessarily high value. It might be good for understanding why your data is bad, which is why I'm not saying it's not high value. But a lot of people just realize the models might not be as useful as they initially thought they were. And so actually, I think for me, there's a real question of how much value do you gain by switching to real time? And if you think about the 80-20 rule, which is like try and get 80% of the impact for 20% of the work, a lot of the time, I've already mentioned this, you don't need to be at real time. Like an hour's latency for analytics is going to give you what you want. So real-time data pipelines, I don't think they're super important in the short term. I think they're going to have really good applications. But people consider those things applications, not data pipelines at that point. So an example of this is people already consume events off a website to understand whether there's something malicious going on, and they're running it through security models in real time or near real time. You're talking about millisecond latency to go, does this look like strange behavior? Could this be a DDoS attack? No. Yes. Shut it down. And that is effectively a data stream that they've consumed and turned into a response.
Yeah.
And that already exists, right? And it exists and it works quite well. We have lots of tools like SKS and Kafka and PubSub for exactly this use case. And that is useful. That is incredibly useful. We all know it is. This is kind of how our apps talk to the sort of the storage backends and stuff. What is real-time analytics then in this context? At which point is it not just an application, or at least what we've traditionally called an application?
And I think as well, like if you consider the cost for the business to implement it, to pay for the infrastructure, to pay for all of that being run, like as you say, is it really relevant? Is it going to bring real value, or is it actually going to cost so much for everyone? Yeah,
you're not actually allowing me to be like devil's advocate here, Dennis. This episode, like, because I had the exact same view. Yeah, exactly. No, but it's jokes aside. I mean, that's the real life. I always have this struggle with real-time analytics as a concept, because real-time analytics implies that, as you mentioned, is an event, something you're looking at anomaly or an alert, and at that point you don't want a human to be part of the process, right? I mean, what's the point? Of course, there is an analytical process happening to trigger, but it's not like
exactly right.
Most people think about real-time analytics. Perhaps I'm not maybe generalizing on having a dashboard on a screen somewhere, like you see on the stock market, but as you mentioned, that's kind of an app rather than real analytics.
Right, exactly. I don't think that's analytics. It's almost not analytics, and it's kind of weird to me. Like, because I think there was an experiment, wasn't there, where they tried to do something with the stock exchange where it's automated, where basically a machine is going to be able to respond to something, to like the changes in the stock exchange faster than a human can see it and respond to it, right? And so, if, you can imagine that anyway. If you've written an algorithm that's responding to the event faster, what's the point in putting it on screen? Like, this isn't useful. The most useful thing about analytics is creating really good, wide-ranging views and then being able to model different scenarios. And then your leadership teams can look at that and go, okay, based on this modeling, this is how I want to take the business forward. But latency is not critical because those decisions are not made in microseconds. And if they are made in microseconds, there must be there are probably strict rules that you've got to be following. And the other thing is, a dashboard is still taking a snapshot of the data at a given moment that it's then visualized. It's not really real time. It's still micro batching or micro refreshing.
Exactly. Yeah. If we look at the biggest picture, so we spoke a lot about data pipeline and integration overall. What are the best practices you will give to people? Like if we look at maybe best practices around integration, around governance, collaboration, or automation, like is there like some must have in your point of view, or some like areas people need to investigate first, to invest first in terms of like development? That massive question, like it should be chopped into so many different pieces, right?
Yeah. It's a huge question. I've got a few different themes that I guess I'd like to sort of dive into. Theme one is security. I have mentioned this, but you may not believe just how many times I look at a piece of data and go, how do you do your access management? Like, it's a very obvious concept. Who can get at your data? How do you ensure your data is secure? And people just go, I don't know. Oh, only the developers have access. I'm like, are you sure? And then it turns out like the whole company has access to someone's like, address and credit card details. It happens because people just think it's in a warehouse and therefore access is restricted. But actually, it turns out there's inherited permissions or something that's happening to everyone that's got that email extension. These are legitimately things that can happen. Like it can happen with Google Sheets really easily. It can happen with anything. So I think that in data, there needs to be a bit of a focus on sort of SecOps, and people like, I'm constantly trying to challenge myself am I doing the best job? The answer is going to be no. There are going to be better things that I can do, but I do try and read about how to secure data and to limit access to it and deploy things in a safe manner. Now, this is the other point, sort of deployment methodologies. Airflow is a very big tool in data engineering. It is a great tool. Not saying Airflow is a bad tool. Well, I'm saying is people will sometimes write a DAG and they would just dump that Python onto Airflow or onto a GCS bucket or an S3 bucket where the managed service just pulls us in and goes, yep, I'm happy with that. This looks like legitimate Python code and it runs at runtime and it's interpreted and happy days. They've never once considered what kind of attack surface they might be exposing through Python packages in this process. Sometimes data engineers will legitimately copy and paste Python files into their DAG. And they will just say these dependencies are what's required. Now, this is where I think data's best practices need to change. And I'm doing my best to change them. But I think there need to be tools like this is CI tools that go, before I'm going to let you deploy anything, even to a test environment, I need to do an OSV vulnerability scan against the packages that you're using and importing. Or even better, you don't actually deploy anything directly to something like Airflow. You containerize it and you do proper package scans on both the packages that you're using, and you actually then do a container test as well. Make sure that the OS dependencies aren't compromised.
Nice.
There are ways of sort of thinking you're going to get to a more secure like deployment using known good images that a security team can help you with. But interestingly enough, this drifts a lot back to software engineering. This isn't different, right? Why should it be? That you should apply the same practices in both data and software from this perspective. And I often think that that's not the case because people in data are often coming from an analytics point of view or a machine, like a data science point of view, and they don't even know how to figure this out. And that was 100% the case for me. The way I learned it was because I got very lucky that my mentor was a DevOps specialist, and she really helped me understand, like, you know, what kind of things I should be looking at testing. And this is one of the things that basically, if you're coming at data from like an analytics or machine learning point of view, it is really worth thinking about because you don't want to accidentally use a risky package. There's like a known risky package as well. That'd be the worst thing because you're not being malicious, but you could unintentionally expose data, right? And that's the worst feeling in the world because you're doing your best, you've written code, it's beautiful, you've written some unit tests, yeah, happy days, and then everyone's credentials get leaked because you used a risky package. Like, how bad would that feel?
I would interpret that as to become like data engineer, like there is a need to learn about DevOps. There is a need to like basically do some preparation on this side as well, because it's part of the job, literally. It's not the first thing that comes to mind, and it's not the commonly taught for people who come in this space.
I think that's really fair, yeah. And I think this is where you start to distinguish between an analytics engineer and a data engineer. At least in my mind, I think different people have different definitions, but an analytics engineer, they are sitting within a SQL space. Everything is in warehouse, and the warehouse is hopefully secure, right? And they're relying on the cloud provider or the warehouse provider to have done the security. As a data engineer, you're actually getting data into that warehouse. You need to think about these security principles a little bit better. Another point, if you don't mind, Mark, going back to, is you talked about the number of tools that exist in data engineering. If you sometimes step back and think about what you need, you should be fairly tool agnostic. I have a set of tools that I love, and that's cool. I fully expect them to be obsolete in the next couple of years. And I just live with that expectation that I should be able to tear bits out and go, something better has come along. And ultimately, I just still need to get data from point A to point B, but I know the consumer wants it in a format, and that becomes your important end step. So I think you just need to be able to really comfortable talking to people to understand what they actually want. And sometimes it's useful to guess a bit about what they'll want next, because you can save yourself a bit of time by extracting things ahead of time. You're like, they'll probably want to expand into this.
And actually, if I can take it there to your point there, then it's about the products. There is this concept that you are quite into it, which is the language of choice for data engineering, which is also, product agnostic. I got to be honest with you. If I think about language for data engineering, Python is the first thing that comes to mind.
So this is a good question. Yeah, I don't think Python is always the right language to use. And one of the reasons for this is we spoke about packages and vulnerabilities, and Python often does open up a number of vulnerabilities that other languages may not. And this is me being a bit of a language nerd, but Python's an interpreted language, right? So at runtime, it has to run. That tends to mean it needs a bigger OS, which has things on it like C++ compilers, etc. So you actually, by using a language like Python, you do increase your attack surface because you need more of an OS, you need more stuff on your OS, and then you have to have a large number of packages, including the parts of them that they're not using, is the way Python, when you import the package, you actually import all of the package regardless of the user. And this is reflected in container sizes. So often when you're doing container builds in Docker or something like Podman, you get really big Python-based images and containers. And as I said, a lot of tools nowadays, you don't have to do a huge amount in the language itself. So I've started using Go myself because Go is compiled it can be run on a fully distroless container, so doesn't have an OS, which means that you have a reduced attack surface, and you host a much smaller container as well. So, we're talking about 10 megabyte containers for applications which are not doing a huge amount. They are just tying things together, and that's all the application needs to do. And we host it on something fully serverless. While the same Python container can be a gigabyte large if it's using something like client libraries that require things to run on top of an OS, and therefore the number of vulnerabilities that it can contain gets a lot larger. Mm-hmm. And there are reasons you would choose not to go down the Python route. Yes, it has a huge number of libraries, but if you're not checking vulnerabilities, it also has the highest amount of risk as a language, I'd say, versus any other language out there. Python is probably the scariest, right? It's also the most amazing and flexible language, which is why so many people learn it. But if your security practices are bad, you sort of have more risk, I would say. That's my opinion. It's a bit of a weird one.
You are actually bringing this into another trend. I know that this is not a trend episode, but we'll talk about a few, which is the multi-language pipelines. I've seen it more and more rising, meaning that within the same pipeline that you have, you can now, for example, certain steps of your pipeline, run it with Go, and then another one run it with Python, another one with, I don't know if you've seen any of those.
I've done this.
Okay. There we go.
Thanks for calling my pipelines a mess, Christian. No, it's good. I think, okay, so this is a good question. I think that the point that can be missed is a lot of the times when pipelines are done like this, they're actually individually packaged containers, right? Which have a given interface, which might be a post request or what have you, which actually means you can have completely language agnostic pipelines as long as they give you a RESTful interface. It means we create essentially an internal API. So initially I might have written it in, I wrote it in Python. I needed to get something up fast, but I noticed that I had a lot of base vulnerabilities, and I rewrote it in Go in time and reduced the base number of vulnerabilities in the container, and I can just hot swap them, right? Because the only thing it cares about is having the same RESTful interface, accepting the same request in the same way. And as long as the functionality is the same, it doesn't matter that you have multiple languages. And that's kind of how I see it, because each node becomes almost a separate microservice. And that's how I run the repos, like a series of microservices, a build per service, which is a container essentially. And then your language doesn't matter.
Amazing. That's a really good use case.
Just to conclude, so question we asked to all of our guests. So what will be the most important piece of professional advice you received in your career so far?
I think the most important thing is just be prepared to fail and try and fail.
Love it. Expect failure.
Well, one of my early mentors said, go play. I'd come and say, oh, what do you think about this? What do you think about that? And he would just say, go play, try it. You will learn so much, even if you don't necessarily produce anything at the end of it. The experience of going and trying something out, and also learning why it didn't work if it doesn't work. And if it does work, massive bonus. But go play. And just always try things. Time box an hour. The value you gain from trying it, even if the business value isn't immediately apparent, is really high, because in the future you're not going to lose time on the solution. You might learn something really great. Yeah. 100%.
Amazing. Love it. Thank you very much, Denis. I mean, as I mentioned at the beginning of the episode, you're a true professional data practitioner. You are at the side, of working with real data, and we really appreciate all your insights for all of our listeners out there.
It was lovely to meet you, Mark, and good to chat again, Christian.
Thank you very much for your time.
Thanks for listening to this episode. This podcast represents our views and not the ones of our employers.
Our mission at the Data Coffee Break podcast is to inform you and help you grow in this always changing data field.
Follow us and get into the conversation with the community on our LinkedIn page and Instagram.
See you next Tuesday, and until then, keep your data caffeinated.